Welcome to the interactive lesson about tectonic activity. Today, we're going to learn about the fundamentals of tectonic hazards. Can some of these hazards be classified as a friend or foe to society? We'll soon find out. Firstly, the movement of rocks in the inner core of the Earth mainly causes tectonic hazards. This is the hottest part of the Earth and the location where the majority of rocks on the Earth are predominantly formed from. The numerous tectonic hazards have different methods of occurrence that range from the rising of magma and tensions between plate boundaries. The Earth's crust is made up of a series of plates which form the surface we live on. These plates are situated underneath chunks of land called continents. Tectonic plates can simply be interpreted as puzzle pieces that intertwine together in the formation of the Earth. Oceanic crust is the formation of new rock through the process of seafloor spreading, in which the basaltic rock rises to the surface of the Earth and expands outwards. The further the rock is from the ridgeline, the older it is. The rocks are expanded over geological time, then form continental crust, which are composed of granite rock. These oceanic and continental crusts are altered in different directions due to the convection currents, which are a series of the rising of magma and then the descending of magma, which creates energy for the movement of tectonic plates. The tectonic plates, the crust, and the mantle are all evidently part of the lithosphere. Although all the continents and landmasses we know today were once part of a land called Pangaea, a theory was once suggested that all 7 continents are in the constant state of movement. This is a theory of continental drift. Prior to the magma rising up the mantle towards the surface of the Earth, it is passed up to the upper core and solidifies. Magma then flows up through the crust of the Earth and causes land masses to move apart. Volcanoes are predominantly found near diverging boundaries in which 2 tectonic plates move away from one another. This exposes vents in the Earth's crust where magma flows from. Of course, there is an exception to volcanoes occurring at plate boundaries. These locations are known as hotspots, in which volcanoes cease to be near plate boundaries. Within hotspots, the magma rises up through miniature cracks in the Earth's crust and causes diabolical earthquakes. The quantity of magma released by a volcano will depend on certain characteristics associated with its structure. The main types are ash and cinder volcanoes, composite volcanoes, and shield volcanoes, each with its own destructive forces. An ash and cinder volcano consists of magma rising up one predominant vent and releases a combination of ash and cinder. The most diabolical volcano, the composite volcano, exerts pressured magma through numerous vents and emits pyroclastic material as a result. Often, this pyroclastic material forms a molten lahar, flowing at a rapid rate down the slopes of the volcano, in the process destroying anything and everything in its path. The third type of volcano is the shield volcano. Shield volcanoes possess a rather large magma chamber and do not pressure the release of magma. It emits lava flows over a wide expanse. The most notable tectonic hazard that cannot be predicted are volcanoes. This is due to the fact that volcanoes possess no definite time period within the specificity of volcanoes. Volcanoes are natural hazards and provide no credible information that is relevant to its next occurrence. Although, we can observe volcanoes that are continuously in the state of dormancy and predict that their next eruption would be quite an explosive and violent one. Earthquakes are another ominous tectonic hazard that release huge amounts of energy. Earthquakes predominantly occur near transform boundaries of tectonic plates. At this location, pressure increases between the 2 tectonic plates horizontally sliding against one another, and eventually the stress is released in the form of movement in the Earth. At these plate boundaries, there are specific fault zones which have an association with a particular boundary that determine the type of stress that is released. Diverging plate boundaries possess normal fault zones. Converging boundaries possess reverse thrust fault zones. And transform boundaries possess strike-slip fault zones. A reverse thrust fault zone consists of one fault line having ascendance over another. This results in the vertical shift of the ground, while a strike-slip fault zone occurs when the ground horizontally moves against one another. And finally, the normal fault zone showcases the movement of the ground in opposite directions. To date, the 1960 Valdivia earthquake in southern Chile is the largest earthquake of magnitude ever recorded by a seismograph at 9.5. This evidently saw the displacement of thousands of people from homes as well as the death of many civilians. The government dealt with one of the long-term effects in relation to the cost of rebuilding infrastructure over a period of years. In addition, the government assisted its people who had lost a beloved family member in the catastrophe. The total economic loss was $24 million. The location where the earthquake initially begins under the earth will determine the ferocity of the magnitude. A deep shallow earthquake begins more than 70 kilometers beneath the earth and is the less destructive type of earthquake, while the shallow earthquakes begin within 0 to 70 kilometers beneath the lithosphere. The location directly above the focus is where the earthquake causes the most predominant damage. This is known as the epicenter. Stress that is released by an earthquake is called a seismic wave, which can be recorded by seismographs. The further seismic waves travel from the epicenter, the more the force of the earthquake diminishes. Earthquakes can also cause the occurrence of a tsunami. This is observed when underwater earthquakes within oceanic crusts release stressful amounts of energy. But instead of the movement of the earth, we observe the displacement of water. Earthquakes and volcanoes are continuously a study in observation because they are unpredictable in relation to geological time. Instead, we can accumulate data from past tectonic activity and perform informed predictions while managing and planning for the impact of the tectonic hazard. So guys, that's all for now. Thank you for listening, and I hope you learned something today about tectonic activity. Thank you.